This is a recast of the 7,100-word piece, Active Learning, from Schneppat.com. This article is about machine learning and active learning, discussing the concepts, techniques, and applications of active learning in various domains. It highlights the advantages of active learning, such as reducing the amount of labeled data needed, improving model performance, and handling unbalanced datasets. It also addresses the challenges and considerations associated with active learning. Let's listen in.
Today, we're diving into the world of machine learning and focusing specifically on active learning. Machine learning has become a hot topic in recent years due to the exponential growth of data and the need to efficiently extract meaningful patterns from vast amounts of information.
That's right, Avery. Machine learning is a subfield of artificial intelligence that allows computers to learn and improve from experience without being explicitly programmed. It involves algorithms and statistical models that enable computers to analyze data and identify patterns and trends.
Machine learning has found applications in various fields such as finance, healthcare, marketing, and transportation. In finance, it is used for credit scoring and fraud detection. In healthcare, it aids in medical diagnosis and predictive modeling. In marketing, it is utilized for personalized advertisements and customer segmentation. And in transportation, it is employed for autonomous vehicles and route optimization.
Absolutely, Avery. The ability of machine learning to make predictions and decisions based on data has revolutionized these industries and has the potential to transform many others in the future.
Now let's talk about the different techniques used in machine learning. There are three main categories: supervised learning, unsupervised learning, and reinforcement learning.
In supervised learning, the algorithm is trained using labeled data, where a target variable or output is provided. The algorithm learns the mapping between input and output, allowing it to make predictions on unseen data. On the other hand, unsupervised learning is used when the data is unlabeled. The algorithm seeks patterns and relationships in the data without any prior knowledge of the output. Finally, reinforcement learning involves an agent performing actions in an environment to maximize a reward signal. The agent learns through trial and error and develops a policy to make decisions.
That's a great overview, Ben. Now let's focus on active learning, which is our main topic for today. Active learning is a machine learning technique that aims to optimize the learning process by selecting and labeling the most informative instances from the training dataset.
One of the key advantages of active learning is its ability to reduce the amount of labeled data needed to achieve satisfactory performance. Instead of relying solely on pre-labeled data, active learning allows the algorithm to actively query the user or an oracle for labels of informative instances. This means that the algorithm can focus on those instances that would contribute the most to improving its accuracy.
Active learning has been successfully applied to various domains such as text classification, image recognition, and computer vision. It has shown promising results in terms of achieving high accuracy with minimal labeled data. This can be particularly useful in situations where data labeling is expensive or time-consuming.
Absolutely, Avery. By reducing the dependence on large labeled datasets, active learning enables machine learning algorithms to achieve higher accuracy levels with less human annotation effort. This makes it a cost-effective solution for training machine learning models.
Active learning is not only important in the field of machine learning, but also in education. It is a teaching approach that requires students to actively engage with the material through meaningful activities, discussions, and problem-solving tasks.
That's right, Avery. Active learning goes beyond passive listening and promotes hands-on experiences, critical thinking skills, and collaboration. By actively engaging with the material, students can apply theoretical concepts to real-life situations and develop essential skills that are highly valued in today's workforce.
Exactly, Ben. The importance of active learning cannot be overstated, as it provides students with the tools they need to succeed academically and professionally.
So there you have it, a brief overview of machine learning and active learning. Machine learning is a subfield of artificial intelligence that allows computers to learn from experience and make predictions based on data. Active learning is a technique that optimizes the learning process by selecting and labeling the most informative instances. It reduces the amount of labeled data needed and promotes active engagement in education.
That's right, Ben. Traditional machine learning methods rely on a passive approach where the model is trained on large labeled datasets. However, this can be time-consuming and resource-intensive.
That's where active learning comes in. Active learning significantly reduces the amount of labeled data required for training by iteratively selecting the most informative and relevant instances for labeling. By actively involving human intervention in the learning process, active learning enables the model to focus on the most critical data points, leading to faster convergence and improved generalization.
Absolutely. And active learning also allows users to obtain more meaningful insights from the data and make data-driven decisions. It's an essential technique in machine learning research and applications.
One popular active learning algorithm is uncertainty sampling. This method selects data points that the trained model is uncertain about. By obtaining labels for these uncertain samples, the model can improve its performance.
Another approach is query by committee, which builds an ensemble of models and selects samples that cause the most disagreement among them. This leverages the diversity of the committee members to identify the most ambiguous samples.
Active learning has been successfully applied in various domains, including image classification, document classification, and natural language processing. The ability to effectively utilize limited labeled data makes active learning a promising approach in machine learning.
Absolutely. In addition to these traditional supervised learning tasks, active learning has found applications in a variety of domains. One such application is in the field of healthcare, where active learning algorithms have been employed to assist in medical diagnosis and decision-making.
By actively selecting informative instances to be labeled, these algorithms reduce the burden of manual labeling for medical professionals and improve the efficiency of diagnosis. Similarly, in the context of information retrieval, active learning techniques have been utilized to enhance document ranking and relevance feedback systems.
That's right. By iteratively selecting unlabeled documents for labeling, active learning helps improve the quality of search results and user satisfaction. These applications highlight the versatility and effectiveness of active learning in diverse domains, making it a valuable tool in machine learning research.
Absolutely. Active learning has found numerous use cases in various domains. In the field of healthcare, active learning techniques have been used to improve disease diagnosis by selecting the most informative data points for annotation. In the realm of finance, active learning has been employed to predict stock prices and identify financial anomalies by actively selecting the most relevant training instances.
Additionally, in the field of computer vision, active learning has been used to reduce the need for extensive manual annotation of large image datasets by selecting the most informative images for labeling, thereby speeding up the training process of object recognition models.
Text classification and sentiment analysis are two important tasks in the field of natural language processing. Text classification involves categorizing text documents into predefined classes or categories based on their content.
Sentiment analysis, on the other hand, focuses on extracting subjective information from text, such as opinions, sentiments, and emotions expressed by the writer. Machine learning techniques, such as active learning, can greatly enhance the accuracy and efficiency of text classification and sentiment analysis by iteratively selecting informative samples for human annotation and building predictive models based on labeled data.
Absolutely. Image recognition is a challenging task in the field of machine learning and computer vision. It involves training algorithms to categorize and identify objects or patterns in digital images. With the increasing availability of large datasets and powerful computational resources, image recognition techniques have significantly advanced in recent years.
Convolutional neural networks, CNNs, have emerged as the state-of-the-art approach for image recognition tasks, surpassing traditional methods that relied on handcrafted features. CNNs utilize multiple layers of interconnected artificial neurons to automatically learn and extract relevant features from raw image inputs. These networks are trained with labeled data to improve their ability to accurately classify new images.
Image recognition has widespread applications, including face recognition, object detection, and autonomous driving, making it a crucial area within the field of machine learning.
Medical diagnosis is an essential aspect of healthcare as it involves the identification of diseases and conditions based on patients' symptoms and medical history. Machine learning techniques have revolutionized the field of medical diagnosis by enabling automated and accurate classification of diseases.
Active learning, a subset of machine learning, plays a crucial role in enhancing the accuracy of medical diagnosis. It involves an iterative process where the machine learning model selects the most informative instances to be labeled by an expert and incorporates this new knowledge into its training set.
This iterative feedback loop helps to improve the model's performance and reduce human effort in labeling large datasets. By leveraging active learning techniques, medical professionals can make more informed decisions and provide better patient care.
In conclusion, machine learning techniques have made significant advancements in the field of active learning, enabling efficient and effective learning processes. Active learning enables machines to learn from a limited number of labeled training examples while actively selecting the most informative instances for further labeling.
This approach has shown promising results and has been successfully applied in various domains, such as text classification, image recognition, and recommendation systems. By actively engaging in the learning process, machines can achieve high accuracy with a minimal number of labeled instances, reducing the need for extensive labeling efforts.
However, active learning techniques also come with challenges, such as selecting the most representative instances and dealing with label noise. Continued research and development in this field will further enhance the capabilities and applications of active learning techniques.
In conclusion, active learning is a crucial technique in machine learning that enhances the learning process by actively engaging the learner. Its importance lies in its ability to reduce the amount of labeled training data required, which ultimately leads to time and cost savings.
Various techniques have been developed to implement active learning effectively. Uncertainty sampling, query by committee, and SVM-based methods are some of the popular approaches that have shown promising results. The combination of these techniques with advanced algorithms and intelligent sampling strategies increases the accuracy and efficiency of the learning model.
Moreover, by allowing the learner to actively select informative instances, active learning provides learners with a deeper understanding of the underlying patterns and relationships in the data, leading to more robust and reliable machine learning models.
In conclusion, assessing the potential impact of active learning on future machine learning advancements is essential for understanding its significance in improving and enhancing the current practices. Active learning has proven to be a valuable approach in reducing the annotation effort required for training models and increasing overall performance.
This technique allows models to actively query informative samples, thereby optimizing the learning process. By incorporating active learning, there is a potential to enhance the efficiency and accuracy of machine learning algorithms, leading to improved decision-making in various domains.
Furthermore, active learning can also aid in addressing the challenges posed by the availability of labeled data, as it enables models to learn from a small labeled dataset initially and then iteratively select the most informative samples for annotation.
Overall, active learning holds great promise for driving the future advancements in machine learning.
Active learning has been successfully applied in various domains, such as text classification, image recognition, and drug discovery. Its effectiveness lies in its ability to maximize learning with minimal human labeling effort, making it a valuable tool for data-intensive tasks.
Yes, and uncertainty sampling is a common technique used in active learning to select the most informative, unlabeled instances for manual annotation. The learning algorithm measures the uncertainty associated with the classification of each data point.
That's right. The idea behind uncertainty sampling is that instances with a high degree of uncertainty are most likely to be informative and beneficial for improving the model's performance.
Different measures of uncertainty can be used, such as entropy-based approaches that assess the level of disorder or impurity in the data.
By selecting instances with the highest uncertainty, uncertainty sampling aims to maximize the learning potential of each labeled example. It's an essential tool in machine learning for efficient data annotation.
Now let's discuss the various uncertainty sampling methods. There are several popular ones, including entropy-based sampling, margin sampling, and query by committee.
Entropy-based sampling selects data points with high levels of uncertainty, measured by the entropy of the predicted class probabilities.
Margin sampling chooses instances that lie close to the decision boundary, where the model is most uncertain.
And query by committee generates diverse opinions by training multiple classifiers on different subsets of the training data and selecting instances on which the committee disagrees.
Each uncertainty sampling method has its strengths and weaknesses, and the choice depends on the specific problem and the characteristics of the data.
That's right, Avery. It's important to choose the right uncertainty sampling method based on the task at hand.
Absolutely. So in summary, active learning is crucial in machine learning as it allows models to make more effective and accurate predictions with less labeled data.
Techniques like uncertainty sampling are used to select the most informative instances for labeling and improve the model's performance.
Active learning has applications in various domains and enables users to obtain meaningful insights from data and make data-driven decisions.
One commonly used active learning strategy is least confidence sampling. This strategy selects instances on which the learning algorithm has the least confidence in its predictions. In other words, it chooses data points for which the classifier is least confident in assigning a label.
The idea behind least confidence sampling is that the instances on which the model is least confident are the ones that are most informative for learning. By selecting these instances and labeling them, the model can effectively reduce the uncertainty in its predictions and improve its accuracy.
However, there is a downside to this approach. It may prioritize selecting instances that are very different from the ones already labeled, potentially leading to a biased sample. It's important to carefully consider the limitations and potential biases associated with least confidence sampling in active learning scenarios.
Another technique commonly used in active learning is margin sampling. This approach aims to select samples that lie in the margin region between different classes. The margin is defined as the distance between the decision boundary and the closest sample from either class.
The intuition behind margin sampling is that these samples are more difficult to classify and thus provide the greatest potential for enhancing the model's performance. By prioritizing the selection of these samples, the model can focus on improving its performance on the most challenging instances, leading to effective learning and improved classification accuracy.
Entropy sampling is another popular active learning technique. It aims to select the most informative instances from an unlabeled data pool. The concept of entropy derived from information theory is used to quantify the uncertainty or randomness in a given set of data.
In the context of active learning, entropy represents the lack of knowledge about the true labels of unlabeled instances. Entropy sampling reduces this uncertainty by selecting instances that are likely to have the highest amount of information. This is achieved by computing the entropy of the probability distribution over different class labels for each instance in the unlabeled data pool.
The instances with the highest entropy scores are chosen for manual labeling, as they are expected to provide the most valuable information for the learning algorithm.
The effectiveness of these active learning techniques has been extensively evaluated in various research studies. Uncertainty sampling, for example, has been found to outperform random sampling in terms of model performance, as it actively selects informative instances for annotation.
However, its performance is often similar to or slightly worse than query by committee, which leverages ensemble-based methods to choose instances for labeling. It's important to note that the effectiveness of active learning heavily depends on factors like the choice of the query strategy and the quality of the labeled data.
It's worth mentioning that active learning techniques have emerged as powerful tools in the field of machine learning. By actively selecting informative samples to be labeled, these techniques aim to reduce the amount of labeled data required for model training.
This can potentially save time and resources. However, it's also important to carefully evaluate and select the most appropriate active learning technique for a given problem, considering factors like the underlying data distribution and the quality of the labeled data.
Further research is still needed to develop more sophisticated strategies and enhance our understanding of the active learning process.
Absolutely. One popular active learning technique is the query by committee, QBC approach. QBC leverages the idea of ensemble learning by constructing a committee of several classifiers. Each committee member is trained independently on a different subset of labeled data.
That's right. During the query phase, the committee members vote on the label of each unlabeled instance, and the instance with the most disagreements among the committee members is selected for labeling. The idea behind this is that by selecting instances on which the committee members disagree, QBC aims to target the most informative and uncertain instances for labeling.
And this iterative process of querying, labeling, and updating the committee continues until a desired level of performance is achieved. This approach has been proven effective in various domains, including text classification, image recognition, and data clustering.
However, the success of query by committee heavily relies on the choice of committee members and the measurement of disagreement among them. These factors should be carefully considered to enhance the learning performance.
Right. Another approach to active learning is the query by committee method, which involves selecting instances for labeling based on disagreement among a committee of models. Studies have evaluated the effectiveness of this method and found that it performs similarly to other active learning methods in terms of overall accuracy.
That's true, but one advantage of query by committee is that it reduces labeling effort and achieves higher precision compared to other methods. It has also been found that merging diverse model predictions in the committee results in improved performance.
However, query by committee has its limitations too. It can increase computational complexity and is susceptible to noise. Further research is needed to fully understand and evaluate the effectiveness of this approach.
Definitely. Data labeling is a critical step in active learning techniques. Manual labeling can be time-consuming and expensive, especially with large datasets. Different strategies such as uncertainty sampling, query by committee, and version space have been proposed to tackle this challenge.
Uncertainty sampling involves selecting instances where the model is uncertain about their label, while query by committee relies on the diversity among a pool of trained models. Version space, on the other hand, maintains a set of all possible hypotheses and actively seeks new information to refine the hypothesis space.
These techniques offer promising solutions to the data labeling problem, making active learning an attractive approach in the field of machine learning.
Absolutely. Now let's move on to stream-based selective sampling. This is a type of active learning technique that aims to select the most informative instances from an unlabeled data stream by optimizing the selection process.
That's right. Instead of considering all the instances in the dataset, only a subset is chosen based on their representation at a given time, which is referred to as the streaming context. This method is particularly suitable for scenarios where data arrives continuously, and the model needs to adapt and update in real time.
Typically, stream-based selective sampling techniques employ a sliding window or a fixed size buffer to store a limited number of instances. Then various strategies, such as uncertainty sampling or diversity maximization, are used to select the most useful instances from this buffer, facilitating efficient learning and adaptability in dynamic environments.
Exactly. The stream-based selective sampling, SBSS, technique is designed to handle large data streams where it's not feasible to store the entire dataset in memory for sampling.
And by considering the uncertainty and diversity of each instance in the stream, SBSS can efficiently select a subset of instances that can train a classifier effectively while reducing computational complexity associated with active learning in large-scale datasets.
Right, so the process involves three main criteria: diversity, uncertainty, and informativeness. The diversity criterion ensures that the selected instances are representative of the entire data stream, giving us a comprehensive understanding of the underlying concept.
That's correct. The uncertainty criterion focuses on selecting instances that are difficult to classify, which helps improve the accuracy of the learning model. And finally, the informativeness criterion aims to select instances that provide the most useful information for refining the model.
By incorporating these criteria, stream-based selective sampling allows us to select informative and representative data instances for active learning in a continuous data stream.
Moving on to the evaluation of the effectiveness of stream-based selective sampling techniques, it's crucial to understand their potential benefits and limitations. Several studies have explored this topic and provided insights into the performance of different algorithms, such as uncertainty sampling and diversity sampling.
However, evaluating these techniques can be challenging due to the dynamic nature of streaming data and the lack of ground truth labels for all instances. Additionally, the choice of evaluation metrics and benchmark datasets can heavily impact the outcomes and comparisons of different techniques.
That's why researchers must carefully design and conduct evaluation studies with robust methodologies to ensure the validity and reliability of the results. This is important for advancing active learning in real-world applications.
Absolutely. Active learning has emerged as a promising approach to improve machine learning techniques. Unlike traditional supervised learning methods that rely on pre-labeled datasets, active learning involves selecting the most informative instances to be labeled by an oracle in an iterative process.
This allows for a more efficient and accurate model by actively seeking out relevant data points to learn from. It's especially useful when labeled training data is scarce or expensive to obtain. Active learning minimizes the need for extensive labeling efforts, saving time and cost associated with training machine learning models.
Active learning offers several advantages over traditional learning approaches. First, it promotes student engagement by actively involving learners in the learning process through hands-on activities and discussions. This enhances their understanding and retention of course material.
And second, active learning strategies cater to different learning styles and preferences, providing opportunities for learners to explore and experiment with ideas in ways that work best for them. This promotes a more inclusive and equitable learning environment.
However, active learning also presents challenges. It requires careful planning and preparation by instructors who need to design appropriate activities and facilitate meaningful discussions. Additionally, active learning strategies may require more resources, time, and effort from both instructors and students, creating logistical and motivational challenges.
Transitioning to the advantages of active learning in machine learning, it allows the model to strategically acquire new information by actively selecting the most informative data points to be labeled. This reduces the need for extensive labeling of large datasets, ultimately saving time and resources.
It also improves the overall performance of the model by focusing on the most difficult samples that are likely to increase its generalization ability. This results in a more accurate and efficient learning process.
And active learning enables the model to continuously adapt and update its knowledge as new data becomes available, enhancing its ability to make predictions in real-world scenarios. These advantages contribute to the success of machine learning techniques.
Finally, active learning is a promising approach for improving the performance of machine learning models when there is limited labeled data available. By actively selecting the most informative instances for annotation, it reduces the amount of labeled data needed to achieve the same level of performance compared to traditional training methods.
Yes, this is especially beneficial in domains where obtaining labeled data is costly or time-consuming. Active learning has also been shown to outperform random sampling and achieve near-label efficiency, making it an attractive solution for small-scale datasets.
However, it's important to strike a balance between exploration and exploitation in active learning algorithms to effectively learn from both labeled and unlabeled data.
Absolutely. One key advantage of active learning techniques is their ability to handle unbalanced datasets. In many real-world scenarios, the training data may not be evenly distributed among different classes or categories. This can lead to biased models that favor the majority class while ignoring the minority class.
That's right. Active learning can help address this issue by actively selecting the most informative instances for labeling. By focusing on the challenging instances, the learner becomes more robust to class imbalance issues. Additionally, active learning can effectively reduce the labeling effort required as it intelligently selects the most valuable examples to be annotated.
And this ability to handle unbalanced datasets is crucial for developing accurate and fair machine learning models in a variety of domains. It ensures that the models are not biased towards any specific class and can make accurate predictions for all classes.
Definitely. Another important aspect of active learning is its ability to reduce annotation costs and time. Instead of passively observing and learning from all available data, active learning algorithms actively select and query the most informative data points for training. This reduces the amount of labeled data required, resulting in significant cost savings.
Absolutely. Active learning techniques intelligently select samples based on their uncertain classification probabilities or by leveraging disagreement among multiple models trained on different subsets of data. These techniques have proven to be highly effective in various domains and continue to be an area of active research.
However, it's important to note that active learning also has its challenges and limitations. One significant challenge is the selection of informative and representative samples for the labeled dataset. This is crucial to achieve optimal performance and avoid introducing bias into the learning process.
That's right. The effectiveness of active learning heavily depends on the quality of the initial labeled dataset and the chosen query strategy. It requires careful consideration and expertise to ensure that the selected samples are truly informative and representative of the underlying data distribution.
Another challenge is the trade-off between the amount of labeled data required and the cost and time associated with acquiring such data. Active learning can be computationally expensive, especially when dealing with large datasets, making it less practical in some applications.
Absolutely. And lastly, active learning may not be suitable for certain types of problems or learning tasks that do not involve discrimination between classes. It is essential to consider the specific problem and domain before deciding to apply active learning techniques.
Moving on, one of the key challenges in machine learning is the identification of relevant unlabeled instances. Active learning addresses this challenge by focusing on how to effectively choose these instances for labeling. There are various strategies used, such as uncertainty sampling, query by committee, and expected model change.
Uncertainty sampling involves selecting instances with the highest uncertainty or inconsistency in their predicted labels. Query by committee maintains a committee of multiple models and selects instances that generate the most disagreement. An expected model change strategy estimates the potential model change based on different instances.
These strategies play a crucial role in improving the performance of active learning algorithms by ensuring that the most informative and relevant unlabeled instances are selected for labeling. This helps improve the accuracy and efficiency of the learning algorithm.
Absolutely. And to further improve the effectiveness of active learning, machine learning techniques incorporate expert knowledge and address the issue of bias. Expert knowledge helps in identifying important points of interest and guiding the selection of informative instances.
That's right. By incorporating expert knowledge, machine learning can make more informed decisions on which instances to actively query for labeling. Additionally, machine learning techniques strive to minimize bias in the active learning process.
Bias can arise due to various factors such as the initial labeled set, sampling strategy, or misrepresentation of the unlabeled data. Machine learning algorithms employ methods like uncertainty sampling and diversity sampling to mitigate bias and ensure a more representative and accurate learning process.
Absolutely. By incorporating expert knowledge and addressing bias, active learning can further improve the performance and reliability of machine learning models.
Another challenge in active learning is the potential for overfitting and noise amplification in the data. Overfitting occurs when the model becomes too complex and starts to fit the noise rather than the underlying pattern. In active learning, this can happen when the selected samples used for training are not representative of the overall data distribution. If these samples contain outliers or noisy instances, the model may learn from these erroneous points and generalize them to the entire dataset. As a result, the model's performance may be severely compromised.
To mitigate this, careful selection of informative and diverse samples during the active learning process is crucial. This means that the selected samples should be representative of the overall data distribution and should not contain outliers or noisy instances. Additionally, using regularization techniques and continually evaluating the model's performance can help prevent overfitting and noise amplification in active learning.
Absolutely. Active learning aims to reduce the amount of labeled data needed for training by selecting the most informative samples to query the oracle. The success of active learning lies in its ability to intelligently select the samples that are most likely to be difficult or uncertain, thus maximizing the learning efficiency.
This technique is particularly useful in scenarios where labeled data is scarce or expensive to obtain. It allows us to make the most out of limited labeled data by selecting the most informative samples to label, rather than relying on random sampling or labeling all instances.
That's right. There are various active learning strategies employed, such as uncertainty sampling, query by committee, and expected model change, which all have their own advantages and challenges. Uncertainty sampling involves selecting instances for labeling that have high uncertainty according to the current model's predictions. Query by committee selects samples that are most likely to elicit disagreements among a committee of models. An expected model change selects samples that are expected to induce the largest change in the model's predictions.